Hi everyone, in this tutorial we will explore the shapes of simple molecules. In this molecule, BeH2, beryllium hydride, we have two covalent bonds. So we have two pairs of bonding electrons. These electrons are involved in bonding. Do we have any lone pairs? No, we don't. So in this molecule we have two bonding pairs of electrons, which are two single covalent bonds. The bond angle in this molecule is 180 degrees. So beryllium hydride, BeH2, has a linear shape and a bond angle of 180 degrees. Another example of a molecule that has a linear shape and a bond angle of 180 degrees is BeCl2. Let us examine now boron trifluoride, BF3, which is made of one boron atom and three fluorine atoms. It has three covalent bonds. Do we have any lone pairs or non-bonding pairs of electrons? No, we don't. So we only have three bonding pairs of electrons. Now let's examine the angle in this case. The bonding angle will be 120 degrees. Let us now check a 3D model of this BF3 molecule where we have three bonding pairs of electrons and no lone pairs. And the shape of this molecule is a trigonal planar, and the bond angle is 120 degrees as we said. So when we have three bonding pairs of electrons, the shape will be a trigonal planar, and the angle will be 120 degrees. Let's now examine a molecule of methane, CH4. How many bonding pairs of electrons do we have in this molecule? Yes, you are correct. We have four bonding pairs, which are single covalent bonds. And do we have any lone pairs on the central atom, which is carbon? No, we don't have. Now let's examine the bonding angle in this molecule. So the bonding angle when we have four bonding pairs is equals to 109.5 degrees, and the shape of this molecule will be a tetrahedral. So this is CH4, it has a tetrahedral shape and a bond angle of 109.5 degrees. You have to differentiate between bonding and non-bonding pairs of electrons. So in this case, we have four bonding pairs of electrons, and the shape will be a tetrahedral, and the angle will be 109.5 degrees. What if we have a total of four pairs of electrons, but one of them is a lone pair, which means that it is a non-bonding pair? So we have three bonding pairs for the single covalent bonds between hydrogen and nitrogen, and we have one non-bonding pair of electrons, which is a lone pair on the nitrogen atom. The bond angle will change in this case, and it would be equal to 107 degrees, so it decreased. And the shape of this molecule is a trigonal pyramid. So this is a molecule of NH3 which has a trigonal pyramid shape, and the angle is 107 degrees. So in this case, we have three bonding pairs of electrons and one non-bonding pair of electron. If we examine water, H2O, usually in water we have a total of four pairs of electrons. However, two of them are bonding pairs, which are the single covalent bonds with H atom, and two of them are the lone pairs on the oxygen atom. So we have two bonding pairs and two lone pairs. The angle in this case will be 104.5 degrees, and this is the shape of water. So a water molecule has a shape of a V. It's a V shape. So when we have two bonding pairs of electrons and two non-bonding pairs of electrons, the shape will be a V shape, and the angle will be 104.5 degrees. Let's now examine the molecule of phosphorus pentachloride, PCl5. How many bonding pairs of electrons do we have? Yes, we have 5 bonding pairs, which are the single covalent bonds between phosphorus and every chlorine atom. Do we have any lone pairs? No, we don't. So the phosphorus atom has no lone pairs. The total number of bonding pairs is equals to 5. Let's now check the bond angle in this case. So we have two angles. The first one is 120 degrees and the second one is 90 degrees. What is the shape of this molecule? The shape of the molecule having 5 bonding pairs of electrons is a trigonal bipyramid. So this is the shape of the molecule. It has a trigonal bipyramid shape, and we have two bonding angles. One of them is 120 degrees and the second one is 90 degrees. And finally, we will check the shape of a molecule which has 6 bonding pairs of electrons and no lone pairs. So sulfur hexafluoride SF6 has 6 bonding pairs of electrons, and the bonding angle will be equals to 90 degrees. And the shape of this molecule is an octahedral. So when we have 6 bonding pairs of electrons, the shape will be an octahedral and the angle will be 90 degrees.